Hey everybody, it's Steph from Destination Exploration here with another Technology Thursday post for our At Home with DE series. Today we're jumping back in with Python, but this time we're working with encryption and decryption coding. Remember that if you have any troubles getting Python up and running on your computer, make sure that you check out part 1. The link to that is in the description below, but it will get you up to the point where you're ready to roll with this one. So let's jump right in. We're going to open up our idle program. So remember that idle is the Python shell that allows us to interact with it in real time. We've got the Python shell up in the corner. And what you're going to do is remember that we can't actually write a program in the shell. We've got to open up a new file and work in there. So you can do that by pressing Command N, Control N, or going up to the top. So I've got my untitled program right here, and we are ready to roll. So the idea with encryption is that all it is, a simple encryption is just taking and assigning a new value or letter or character to the original letters in every message. Basically scramble all of the letters to something new so that the average person can't see it or they can't decode it without using the key or the cipher. So that's just what we use. It's kind of the mathematical equation that will be able to move the position of basically the old letter to the new encrypted letter. So let's get started off here. We want to prompt the user to write in their secret message that they want encoded. Okay, so we're going to create a variable called message, and we're going to make it an input, which means that the user has to decide what that variable stands for. So we're going to use the input. Remember, it's turning purple. We're going to open our bracket, use our quotations, and we want to make sure that it turns green. So we're just going to write a prompt here. Enter your message. Your secret is safe with me. And remember, leave that space there so that their message comes after, and we're going to close the quotation and close the bracket. So remember, we do want it all to be green and then the end bracket to be black there. All right, so let's jump on down to the next line. And what we're going to do is we're going to make the key. So the key is the value that we're going to shift the letters, or we're going to apply to each letter in the original message so that it can find the new letter. So the encrypted letter. And that's what we're going to use again to decode the message. So we're going to make the key. So we're going to call this the num key as our variable, and we're going to use the key. So instead of just a random letter, we're going to use the number of letters in the person's name. So we're going to make it another input. We're going to go, what is your name? Close the bracket. And all good there. So when the num key comes in, that variable is actually a string. So remember, a string is just kind of like a stamp that doesn't have any values to it inside of it. It has individual letters, but we can't do anything. So if I were to write, say, Steph, which is 5 letters, we wouldn't be able to use Steph as, say, a value, the number 5. So right now we've got the message. We're getting what the secret message that we're going to encode is. The num key is the name of the person. So now we have to figure out, we have to tell Python what possible letters can be used in this message. So remember that Python can distinguish between uppercase and lowercase letters, so we have to add those in. It can distinguish between spaces and all the different characters as well. So just like before, in our strings, we have to basically define what all of those possibilities can be. So we're going to call it the bank, so like the letter bank. And what we're going to do is we're going to use the double bracket here so that everything that fits inside of it is going to be part of this letter bank that Python can look at. So we're first going to write the alphabet in capital letters, then a space, then lowercase, and then all the special characters. So I've got the comma, the quotation, the question mark, the exclamation mark, because that's always useful when sending messages, a period, a money sign, and for Nan, and then we're gonna do all the numbers. So, and then we're gonna close that bracket again. So this one doesn't have a bracket at the end because again, it's just a variable. So it's not an input or a function. So the functions have the brackets, but this string just has the quotations at the beginning and the end. It's important to realize how many characters are in this string because there's actually a position in the string. So it doesn't necessarily have a mathematical value, but Python can distinguish between each character within that string. So it can tell that A is in the first position, B is in the second, C is in the third, and so forth all the way down. So if we do some math in here, so remember we're just going to use the hashtag sign as basically comment so it doesn't do anything to our code. So if we have 26 letters in the alphabet plus 1 space plus another 26 lowercase alphabet, 8 special characters plus 10 numbers. So that is a total of 71 characters within that string. So that's important. So it doesn't matter what you put inside of this. So if you wanted to put in different special characters or take some out, you just have to make sure that you understand and count how many letters you've got in that string in the bank, okay? So what we have to do now is that we've got the message that the user is putting in, the name that they've put in, and the bank of letters that can possibly use within the message. So what we've got to do now is we have to make this key, this cipher. So again, we said we were going to use that from the name that the person inputted. So what we have to do is we have to count how many letters are in that name. So what we can do is we can just count the number, the length of that string. So Python, again, can distinguish between how long a string is and how many characters are in that position. So all we have to do is we're going to create a variable called key, and that key is going to be the length of our string num key. So the length function is something that's already built into Python, which is great. So we're going to take advantage of that. So now if I were to go in here and I write num key equals Steph, make that a string, okay, and I went the key equals the length of the num key, and I typed in key, I should get 5. So that's an easy way of checking it there in the Python shell. So now we need to create the encrypted variable so that we can then at the end of this print it out and show it to the user. So we're going to write an encrypt variable, and we're going to make it just a blank string. So just 2 quotation marks. So there's nothing inside of it. Okay, and we're going to build with that using a for loop right now. So what we need to do is we need to tell Python to look at each individual spot or position of the message, look at that letter, check where that letter is in the bank, add the number of positions of the key, so let's say 5, and find the letter that's in that position in the bank as well, so the new position. Okay, so a for loop is just like a while loop, which we used in our last tutorial, but a for loop will be able to go in and just kind of, it doesn't have any conditions to it, so it's just going to do that. So for everything in this sentence that's going to be true, it's going to do the following. So we're going to use I, which is indexing for I in message. So message is our variable, so that's this message up here, and I is the position within the message, which is a string. Use our colon. And remember, we're getting that indent, and that's important. So what we're going to do is we're going to look at the position. The position equals bank find I. So what that is it's a function. It's saying the position variable is going to equal finding I. So whatever the first letter of our message is, we're going to find it in the bank. So let's have a message up here in our science is fun. That is going to be our message going forward. Okay, our sample message. So for the first position in the string, it's going to look for capital S. So capital S is 19th position in our bank. So the position equals 19. And what we're going to do is we're going to create a new position, which equals the position plus the key. So remember that we've taken the key, and that equals the length of the person's name. So we're going to add 5 to 19, which gives us 24. And so the 24 letter in the alphabet will be X, because there are 26 letters in the alphabet. So it should return X as our first option here. Then the only issue that we have to account for is that if we were to have a message that had the number 7 in it. 7 plus 5 is 7, 8, 9, and then we go into this blank area. And Python will return an error. So we have to tell Python to go back to the beginning and start again and start counting from there. So in order to do that, that's where our number of characters in the string comes in handy. So we're gonna do the percentage sign, which is like the divide sign, and we're gonna divide by the number of the length of the bank. So you can either do 71, or if you want to keep changing the letters in your bank, you can actually put it in, we can make a new variable here that is bank length, which will equal the length of the bank. So then that becomes a number, so then we could do divided by the bank length. Okay, same idea, but we're just going to keep it as 71 for simplicity's sake, so that we can see it and there's not too many words. So now we're adding 5 to that position, and then we're going to add that new letter in that position, the new position, into our encrypted string. So we're going to add, and to add something to the string is we're going to do a plus and an equals, and then we're going to go add that letter in the new position. And so we want to make sure that we're using these square brackets because that actually tells Python to pull that character out of that position or out of the new position within the string. So it's going in. So it's a kind of a vector inside the string. And that's essentially it. So now all we have to do is go back, get out of that indent. We're going to print out encrypt to test it out. Easy peasy lemon squeezy. So let's give it a try. So remember, what we do have to save it before we run it. So we can go up to the top and go run module. It's going to ask it to be saved. Just saved on the desktop here. Awesome. So enter your message. Your secret is safe with me. I'm going to write science is fun. Name is stuff. So my encrypted message is now this crazy bunch of letters that really has no meaning to anybody else except for you and I. So again, as a user interface, this looks kind of wonky. So let's add in a string here to help us understand what these whole bunch of letters are. So again, we're going to add in a string to this. So we're going to say your encrypted message is the following. And then to add a string to a string, we're just going to use the plus. So there we go. Let's try it again. So we're going to type in science is fun. What's my name? Your encrypted message is this. Amazing. All right, so the first half done. Simple. We're good to go. Except, what are we gonna do with this encrypted message? It really means nothing except that you've jumbled your letters and spaces. Okay, so now we have to do the decrypting. We're essentially going to do the opposite. Okay, we're going to change the variable names a little bit, but the whole for loop is just gonna be, we're gonna take that position of the funky character, the encrypted character, we're gonna subtract the key, so the same key we used at the beginning, and then we're gonna find the new position of the original letter, okay? So I'm just going to put in a whole bunch, a comment line in here so that we can see the break. So anything above the hashtags are our encryption, and anything below will be our decryption. But it will all still run in the same program, so that's a-okay. So to start off, we've got to then, let's give it a couple of lines so that the user can see it a little better, and then we're gonna ask them, are you ready for your answer? Okay, so we're just gonna use the print function. We're going to print in, so to make a new line, it's just /n, so we'll give them 2 new lines, and then we're going to type in a question here for your message. Okay, and then what we're gonna do is close that bracket. We have to get the user to tell us what the encryption key is, because again, we don't want the message getting into the wrong hands. So we're gonna write the D key which is like the decryption key, and it's going to be the input function. So we're going to get the user to tell us what it is. Then what is the magic number? All right, so this is going to, you have to tell the person that you're sending the message to, being like, it's the number of letters in my name. So the D key input, whenever we get an input from Python, it becomes a string no matter what, even if it's a number. So what we've got to do is we've got to first turn that number into that string into an integer. So the integer again actually has a value. We can use it within math equations. Okay. So first thing we got to do, we got D key equals. We're gonna just change it. So we're gonna go with the integer of D key to the original value string there. Okay. Now, just like with before, we had this encrypt blank string. We're going to do the same thing, except this time it's going to be the decrypt. And it's just going to be another blank string there. Okay? We're going to do the same for loop from before. So what we can do is we can even copy and paste it. All right? Except this time, if we use the position, it's going to take everything from the encrypted part of the code. So we've got to change it. So all I'm going to do is just change it to pose, bank, find I. Again, we're not checking in the message, we're checking in this encrypted string that was there before. So it's not looking at that original message, it's looking at a different string. Perfect, so it's for every position within the string that is encrypt, which is this variable up here. We're gonna find a position in the bank. We're gonna create a new, so we're just gonna make it position. And then we're going to have that position, and then instead of adding 5, which is what we did before, we're going to subtract 5. And it's not the key because, again, we want to make sure that we're using the user's key just to make sure that it's the right one. So we're going to do D key divided by 71, which is great. And then what we're going to do is we're going to add it to the decrypt string at the new position. So the decrypt key, we're adding in that new character into that string. Easy peasy, lemon squeezy. So now we should be good to go. We're going to go back here, get out of that indent. We're going to print. We're going to do the num key. So this, we're just going to call back the person's name. So the original senders as part of our kind of output sentence. So it's going to be like, Steph wished to tell you our decrypted message. So we're going to add Steph. And then we're going to make it a key or a string. So add in a space there. Wishes to tell you ... make it ominous. Add another space in there because remember that the decrypt string starts with no space in front of it. And then we're going to add decrypt and close that bracket. So there we go. Let's try it out. So we're going to go back here. We're going to run it again. So enter your secret message. So science is fun. Not so much a secret message, if I do say so myself. So our name is Steph. So again, we get our encrypted message, which is up here. Great. We got 2 line spaces. Perfect. Are you ready for your message? Then what's the magic number? Our magic number is going to be 5. Steph wishes to tell you science is fun. Yes. Now, what happens if we run the program again? We do science is fun. We write in my name, but then we put in a magic number that's 4. It's going to do the same thing, but I'm still going to get Steph wishes to tell you gibberish. So it means that I don't have the magic number, I don't have the key. And that is a very simple way to encrypt a message and send it over to somebody else and have them decrypt it. So that is encrypting messages in Python. So just like before, we've got a walkthrough PDF to help you out here with kind of some explanations in case you want to work through it without the video, which is totally fine. So that's just here. It'll be on the regular post. The link to that is in the description below. Okay, and it's got the final code here at the end. So again, we've got our encryption code at the top, we've got our decryption code underneath the comments, and easy peasy lemon squeezy. So right now, when you run this program, the user can see the original message when they're trying to decode it. The challenge for you is to try and make it so that the user or the person that you're sending your message to has their own Python program that they have to put the encrypted message in as well as the key in order to get the simply decrypted message. So your hint is that you've got to make 2 programs and run them on separate computers or run them at different times. And then you can send messages across your house, over to school, send them to your friends, and nobody will be able to figure out what you're trying to say. And depending on what you put in your bank, you can put some crazy things in there. You could write a whole essay in encrypted language and your teacher wouldn't even know. But don't blame me when this happens, because make sure you give them the decryption key. All right, so that's a simple way of doing encryption and decryption within Python. I hope you had a great time. Again, if you want to walk through the steps, the links to that are in the description below, as well as the original Python number game is in there that you can give a try if you missed that one. So until next time, thanks so much, and we'll see you then.